Hello everyone, you are welcome to another segment of our class. So where we are going to be taking a look at the last examples under volumetric calculations. Example 9 says that calculate the mass of hydrated ethane dioic acid, which is this, needed to prepare 5.0 dm cube of 0.105 molar solution. Now, you get to observe that, okay, which formula are we going to use? So, you have to realize that we have volume given as 5.0 dm cube. So, we have concentration given, which is 0.105 molar here. And we are asked to calculate the mass. Can you see that? Mass is what we are to calculate of this very particular chemical substance. So, you remember the formula we said that, okay, C is equals to N over V. You remember? So, this is the formula that can suit our problem here. So, but there is a problem. We don't have mass given. So, we said, remember that we said N is equals to mass, okay, over molar mass. Yes, I believe you remember this very particular formula. So, in this case, we are going to substitute in this for N here. So, we said this implies that C, which is the concentration, we have mass over molar mass all over V, okay? So which is equals to, we have mass over molar mass times V over times 1 over V here. So this is exactly what we are going to have. Are we together? By taking the multiplicative inverse. So in this case we say, okay, C is now equals to mass over molar mass of ethane dioic acid times V times 1 over V here, okay? So, we already know what our C is, so we just go ahead and substitute. So, we have 0.105 is equals to mass here, we don't know. So we just write it down over molar mass of ethane dioic acid. So ethane dioic acid, which is H2C2O4.2H2O, we calculate it. We say that, okay, this is equals to, we have 2 plus carbon is 12, 2 times 12, that is 24, okay, plus 4 times 16, that is 48, plus 2 times 18 here, okay, so 16, write down 6, carry 1, so we have 36, okay. So you get to realize that here, what do we have? This is 50, this is, we got 50, we have 24 here, okay, we got 36 here. So when we add everything, this is 10, 0, carry 1, this is 8, 10, 11. So 110. So that is 110 as molar mass here for this guy, grams per mole, okay? That is the molar mass here. So we now have this to be 110. So in this case we say, okay, our mass here, mass is now going to be equals to 0.105 times, oh, we are mistaking something. So we have 1 over volume, and our volume is 5, okay? So what do? We just have to go ahead, calculate, and push over. So we have our 0.105 is equals to we have mass divided by 110 times 5. 0, we got 5, we got 5. So this is 550. So 550 here. So it implies that we have what? We have our mass. It implies that mass of ethane acid is now going to be equal to 0.105 times what? 550. So what do we have at the end of the day? So we have 0.105 times 550. So we have 57.75 grams as our final answer. Okay, so that is the mass of ethane acid that we are going to have, but we have to be very sure. We check. Now I said ethane acid here is H2C2O4.2H2O. So here we have 2 plus 24 plus 4 times 16. 64. My goodness. Plus 2 times 18, we have 36. Please pardon me for that. So when we add up everything, we have 2 plus 24 plus 64 plus 36. We have 126 grams per mole. Please. So we have to change it. So here is 126. Is that okay? So when we go ahead, we multiply this 126 by 5. So we are going to have 630. Okay, so we multiply here. That is 0.105 times 630. We are going to have okay, so our final answer is 66. Okay, 66.15 grams. So that is our final answer. So that takes us to example 10. Example 10 says that if 4.16 grams of barium chloride was dissolved in water, which the volume given is 200 milliliters, so we have to calculate the concentration of the resulting solution in moles per dm cube. Wow. So remember, we already have mass. Okay, so mass given is 4.16 grams. Then we have the volume given, which is 200 ml. Wow. So what do? We have to calculate the concentration in moles per dm cube. So this volume have to be converted to 1000. So to do that, we use the relation which says that mass over molar mass is equals to CV divided by 1000. So we make our C to be the summation of the relation here, but let's substitute everything. So this is equals to, the mass given is 4.16 divided by molar mass of barium chloride. So barium is 137 as the molar relative atomic mass. 137 plus 35.5 times 2, okay, which is equals to C times the volume here is 200, everything divided by 1000. So it implies that we have 4.16 divided by 35.5 times 2, we have 71, okay, which is equals to C times 200 divided by 1000 here. So our concentration now is going to be 4.16 times 1000, okay, divide by what? Okay. Yes. Divide by 71 times 200. Okay. So in this case we have 4.16 times 1000. So this gives us 4160 divided by 71 times 200, which is 14,200 here. So when you carry out the division, at the end of the day, we have 0.293 moles per dm cube as our final answer. So this is the concentration of the acid solution, of the resulting solution. So let us check in our notes. Have we arrived at the same answer? Wow, what we are having here is quite different. So what we have here is 0.1. So what is the problem? So what are we missing? Let us check. Mass given is 4.16. We have the volume there. So okay. What are we missing? Molar mass of barium chloride. Barium is 137. So 35.5 times 2 plus 137, so it's 208. Wow, you can see what is going on here. So here's supposed to be 208. That's the mistake we have done. 208. Yes. So that is that. Pardon me for that. So when we multiply everything here, so here is going to be 208. Okay. So here is going to change also. So 208 times 200, we have 41,600. So in this case, 4160 divided by 41600. So we have 0.1 dots. Right. So that is exactly what we have as our final answer, which is 0.1 moles per dm. So that is that. I hope this helps. So thank you very much. Until we come your way next in our next class. So have a wonderful time and bye bye.